Okay, welcome back. So just still working on this one, just trying to finish it up. We're just working through the algebra now. So we have the x times the sine of 79 degrees over 87. And we're trying to solve for x here. As complicated as it looks, remember that a lot of this is just numbers. So sine of 79 is just a number. 87 is just a number. So I'm going to multiply both sides of the equation here by 87. So I'll get x times the sine of 79. And that's going to be 87 times the sine of 23. Again, this is all just numbers over here, but I'd like you to keep it exact as long as you possibly can, so don't round this if you can avoid it. And then I'm going to finish this off by dividing both sides of the equation by sine 79. Okay, so I'm going to wind up with, once those cancel, x equals 87 times the sine of 23 divided by a sine of 79. So run all that through your calculator, and you should end up with approximately, to one decimal place, 34.6. Okay, so hopefully that works out. Again, once you have it set up, it really just is algebra. It just takes some getting used to, but once you do a bunch, it becomes a lot easier. So what I'd like you to do now, take a look at B, and again, just ask yourself, what am I being given here? What law can I use to solve for something? I'm going to be trying to use sine law, and we're going to try using cosine law here. So think it over, talk it over with a partner if there's anybody there with you, and just see what you can get, and push play when you're ready to talk about it. Okay, so what you want to ask yourself first is, do I have a side angle pair? I do not. I have this 43 degrees, I don't have the side. I have the 5 centimeters, but not the angle across, and I have the 7 centimeters, but not the angle across. So sine law will not work here. I have to use cosine law now, and I can only use cosine law in this situation to solve for the side across from the angle I'm given, which in this case happens to be what we're looking for. It's side C. So to set up my equation here, I'm going to have c squared. Okay, you can use the formula I gave you in the previous slide as reference here, but to build this, we're going to have c squared. It starts off like Pythagorean theorem, so I'm going to have c squared equals a squared plus b squared. And the rest of it now is going to be minus 2ab times the cosine of the angle across from the side we're looking for, which in this case is the angle C. Okay, so this is going to be my cosine law equation that I'm going to work with. Okay, at this point now I just need to sub in everything I know. So side C is my unknown. Side A is my 5 centimeters here. Side B is my 7 centimeters, again, across from angle B. 2 times 5 times 7 times the cosine of 42 degrees, or 43 degrees, sorry. Okay, and in theory I can run this all through my calculator, but let's just simplify it first. 5 squared is 25. 7 squared is 49. Here I'm going to get 70. Okay, so just taking this a little bit further. It's the first one, so I'm going to go through a little bit more detail with the algebra. Remember, this is all equal to c squared. This is going to be 74. Okay, and one of the most common mistakes I see is I'll have somebody on the next line tell me a situation like this. The next line is going to be 4 cos 43 degrees. It's a very common mistake, and maybe you actually did this on your own when you're working through it, but think about why this wouldn't be the case. Remember that this right here is 70 times the cosine of 43, so it's 70 times a number, times a ratio. Okay. Following your order of operations, your bed mass from grade 9 and earlier, the multiplication has to happen first. So this is not correct. Okay, you'd have to do 70 times cos 43 first and then subtract it from 74. Okay, just keep that in mind when you're working through it, because that's a really common mistake I see. So at this point now, we're trying to solve. Remember, this is all equal to c squared, so you have to get our answer by taking the square root of both sides of the equation. So do 74 minus 70 times the cos of 43 degrees, take the square root. Now, technically this is plus or minus the square root, so we're taking the square root of both sides, but the negative one isn't really It doesn't really matter in this case because we're talking about a length. So it's just going to be the square root of 70 minus 70 cos 43. And that's going to be equal to approximately 4.8 centimeters. Okay, so cosine law looks like a complicated equation, but again, once you set it up, work through the algebra, it's not too bad. Okay, let's keep going. I would like you to try this one. You know, at least try setting up the equation first, seeing what you'd want to use, sine law or cosine law, and then getting your equation with the unknown. Try and solve it too, but if you get stuck on the algebra, we'll go through it obviously. So push pause and push play when you're ready to go through it. Okay, so I'm looking for, in this case, angle alpha. But again, what do I have to start with? Do I have an angle side pair? Yes, I do. I have the 3.1 centimeters, which goes with the 22 degrees. So that means the sine of 22 degrees over 3.1 is going to be a ratio that I can use. Now, what do I compare it with? Well, I'm looking for angle F, the alpha here, but I don't have the side across from that, so I know nothing from this ratio. So I can't yet do sine F over side F because I don't know any of those yet. What I can do though is work with angle D and side D, which is a 7.9. Okay, so instead of this, pardon me here as I erase, I'm going to do sine D over 7.9. Okay, and now this I can actually solve. There's only one unknown in here. So multiplying both sides of the equation by 7.9. Notice that here my unknown is the angle. I got to get the ratio by itself first. Okay, so I'm going to multiply by 7.9. So I get 7.9 sine 22 all over 3.1. Okay, and now I have to solve for this angle D. Now, how do I solve for an angle? Just like with SOHCAHTOA, whenever you're solving for an angle, we had to use the inverse function. We're going to do the same thing here. So I'm going to take the sine inverse, switching to green here, the sine inverse of everything I had here, which was a 7.9 sine 22 over 3.1, and that should give me angle D. So try running that through your calculator, and it should give you that angle D is going to be equal to about 72.7 degrees. Okay, so great, we found an angle. Are we done yet? Unfortunately not, because remember that's actually not what we were looking for. We're actually looking for angle F, but it's not too bad from here, because look, we've got 2 of the 3 angles in a triangle. We have the 22, now we have 72.7, and now we can solve for alpha, or angle F in this case. Now I know that this is rounded, but we don't really have a choice. You have to use a rounded value in this case. So we can find alpha by going 180 minus 72.7, which is the one we just calculated, minus 22 degrees, which when all is said and done should give me 85.3 degrees. Okay, having fun yet? Hopefully you are a little bit. Let's try another one. So, I'm giving you a triangle here. I'm giving you a side length and 2 angles. I want you to solve the triangle. Remember what solve the triangle means? It means you are finding everything that's unknown. All the missing sides, all the missing angles. So I want you to try and draw the diagram for yourself first. If you're looking for where to start, remember the naming conventions, right? That angle P should be across from side P. So draw the triangle on your own and try and solve for all the missing sides and angles using whatever the appropriate method is. Okay, so pause it for now, give it a try, and push play when you're ready. Okay, so there's your diagram. Again, the important thing is here, angle P and side P have to be across from each other. We have 2 of the 3 angles, so we can find out the third angle. In this case is angle L, so that one should be 95 degrees. So when you're solving now, do we have an angle side pair? Yes, we do. We have the angle P and side P, so now we can use sine law to solve for something. So you can choose whether you want to solve for side L or side M first. If you're solving for L, you will have the equation of sine 30 degrees over 92. Okay, that comes from angle P and side P. So for L, let's say we're going to have sine of 95 degrees over L. Okay, and you need to work through the algebra to solve. Again, you just multiply both sides of the equation by L, and then rearrange. And that should give you about 183.3. Okay. Similarly for M, set up the equation. Again, if you want to, you have to choose here. Well, you don't have to choose. There is a choice between using the side we just calculated or the one that's given. Remember, to keep things accurate, use the ones that are given because those ones you know they're not rounded. So we'll have sine 30 degrees over 92. Again, that comes from angle P and side P. So for M, we're going to have the sine of 55 degrees over side M. Okay, and again, it's just algebra from here on in. I know it can be tricky, but again, remind yourself, multiply both sides by M. So you're going to get M times the sine of 30 over 92. Okay, and just to finish it off, if you're solving for M, you would then multiply both sides by 92. So you're going to get 92 sine 55. And then you're going to divide by the sine of 30. So that's where all that comes from. And you should wind up with, after that, a value of about 150.7. Okay, and don't forget our units here. This should be in centimeters, so should this one over here. Okay, do a couple more examples before we call it a day. Okay, so in this case, we have two angles of a triangle being 30 and 65. The longest side is 34. I want to know how long the shortest side is. So looking at a diagram first, the third angle in this triangle is 85 degrees. Okay, again, because they have to add up to 180. So if the longest side is 34, the longest side is across from the largest angle. So that means that the 85 degree angle has to be across from 34 centimeters. And wants to know how long the shortest side is. Well, the shortest side has to be across from the shortest angle, which in this case is 30 degrees. Okay, so that helps generate our diagram, and then we have to try and solve for x. So I want you to do this one completely on your own, and push play when you're ready to see the answer. Okay, now one thing I should mention here that may help with the algebra for those of you that are still struggling with it a little bit. In this case here, if I want to solve for x, this is the angle side pair I know, so I'm going to have the sine of 85 degrees over 34, which is going to be equal to the sine of 30 degrees over x. 30 degrees over x. Okay, now it can be confusing sometimes when the variable's in the denominator. I know the algebra works, but one thing to remember here is when we have our sine law, the sine law that says that sine a over a is equal to sine b over b, and so on and so forth. Well, I'm allowed to take the reciprocal of both sides because it's an equation, so as long as I do the same thing to both sides of the equation, that's okay. So I could also have a over sine a equaling b over sine b. And the benefit that you might see from using this form instead in this situation is that we wind up with, instead for an equation, 34 over sine 85, and then x over sine 30. Where this becomes a little bit easier now is that in terms of the algebra to solve this, all you need to do is multiply both sides of the equation here by sine 30, whereas up from here I have to multiply it by x, and then multiply both sides by 34 and divide by sine 85. So it cuts down the algebra a little bit, which is never a bad thing, especially if you're pressed for time. So you can keep that in mind and use that as a potential of getting to your answer as well. So what you wind up with in the end, after these cancel, is about 17.1 centimeters. Okay, it's just a little bit, again, just another way of writing the equation that might help and make the algebra a little bit easier. Okay, so the rest of this video is going to be continued on in part